Haijin Zhang from Hanwha Corporation. Thank you so much. And let's give him a round of applause.
Good afternoon. I'm Haijin Zhang, serving as the Chief Information Officer and Chief Digital Officer at Hanwha Corporation in Korea. It's a great honor to be here at the beautiful San Francisco today, sharing our journeys with CIOs, CDOs, the person in charge of data, attending Databricks AI and Data Analytics Summit. The focus of my presentation is, as indicated by the title, is maximizing data value with Databricks. By the end of my talk, you will see not only the reference of data collection, analysis, and visualization, but also use cases into the role of GenAI-based chatbot. Before I proceed, let me explain what the system means. A fusion of Hanwha and advanced data analytics platform. Hanwha Group was established in 1952, a global multi-billion-dollar enterprise with a diverse portfolio in aerospace, energy, finance, retail, and services. With a footprint spanning the Americas, Europe, Asia, and Oceania, we are South Korea's seventh largest business entity, a member of the global Fortune 500, and one of the Time 100 most influential companies in 2024. As a flagship store within Hanwha Group, Hanwha Corporation achieved a revenue of $5.3 billion last year. The corporation comprises three distinct companies, each with a dynamic portfolio in explosives, trading, chemical, machinery, and engineering and construction. To address Hanwha's top priority, an integrated system that seamlessly connects various database and systems across divisions, we urgently needed a real-time unified information interface. Traditional integration methods are expensive, time-consuming, and incompatible with our strict schedule. To illustrate the siloed system, the Global Division and Momentum Division use the same ERP CC6, while the ENC Division uses S/4HANA. Each division operates with its own databases and systems, resulting in fragmented data management. Additionally, there was an absence of a unified data platform, standardized analysis tools, and a cohesive data governance. Among many examples, I'll guide you through the financial closing process. Before implementing Hanwha's new system, each division's closing staff had to manually report the result to the corporate closing manager. This process was time-consuming due to the numerous manual tasks and the extensive time required to verify data accuracy. Additionally, the lack of data governance posed a risk of unauthorized employee can access enterprise data. By leveraging Databricks, we have significantly enhanced the timeliness and accuracy of data collection. This has removed manual work, allowing power users to focus on difference analysis. Through Unit Catalog and its role-based access control, each division can only access its own data and not pry into other systems. Only selected personnel with specific role and responsibility from the overarching enterprise can only view the entirety of the database system of the organization. This not only is successful in implementing a critical security layer to governance, but has also led to improve data ownership and a pivotal shift toward viewing data as an actual product. Now, dashboards are immediately accessible to both users and top management. This is the most important slide in this presentation. On the left side, we showcase various data sources from each division, utilizing various methods for data ingestion, including JDBC, AWS, DMS, RFC, and OPC. The data is stored within Databricks. Data engineering sector where we perform data engineering tasks and retrieve data using SQL. The SQL service retrieve data retriever and machine learning functions are connected to designated for AI project. Unity Catalog manages data governance and access privileges. Application servers are implemented as EC2 clusters by function, and S3 buckets are organized by division. For visualization, we've developed a dashboard that users can access via Tableau and MS Power BI. GitLab is used for managing development resources. So the red line highlights our GenAI-based chatbot, AIDA, AI plus data analytics. The global division leverages Oracle Unifier as a project management system. We handle both structured and unstructured data. The AIDA converts this data into vector data type on our locally hosted in a vector database. We employ DBRX as our primary LLM to answer business and general queries from our employees. In summary, our Databricks platform is adapting at collecting, analyzing, visualizing a wide variety of types of data, and it is designed to manage and streamline data operations across diverse data sources effectively. There are two important tasks when building AIDA: generating knowledge bases and configuring a chatbot. AIDA utilizes the retrieval augmented generation (RAG) approaches and leverages features from OpenAI to generate the knowledge base and configure the chatbot. The left side of the slide illustrates the generation of knowledge base. As you can see, documents and databases are connected to the data embedding application. When data is sent to OpenAI by this application, it chunks and embeds sentences and returns the result. The knowledge base is completed by saving the embedded data stored in our locally hosted vector database. The right side of the slide is the actual user side configuring the chatbot. When the user asks a question, it embeds that question and searches its knowledge base. The chatbot sends that question along with the most similar embedded values from each knowledge base. Then OpenAI generates response and returns the answer while referring to our embedded set of documents as a context which result in. the user finally receiving a more cohesive answer than off-the-bat ChatGPT. In this part of my presentation, I'd like to introduce AIDA, or GenAI-based chatbot. There are three main menus at the top of the screen: Q&A, document analysis, and AI translation. The left side of the slide represents knowledge bases, which covers a variety of items related to business. We provide Q&A on Korean legal code, regulations on industry, company policy guidelines, and insights from closed project. Users can select a specific knowledge base and ask questions. Users can also rate the quality of the answers, which is important to improve the accuracy of responses. Typically, people talk about GenAI-based chatbots that are developed based on document files. But for this particular use case here, we've developed retrieval augmentation for our plant unit teams with connections to an actual project management system with key insights from past projects being readily accessible using natural human language. This greatly improved the issues related to knowledge passover during HR reshuffles, new hires, senior members of the company retiring, being replaced with the new team members with no insight to our previous practice. Key project information metadata, a summary of issues and outcome of the project, as well as a direct link to the project management system at hand via our project management system can be quickly provided. As a next step, we plan on scaling out our setup to other project management systems within our group. People building this system, we thought aloud whether to go on premises or deploy to public cloud. After performing TCO analysis, we decided to select Databricks. Calculating TCO over 5 years, we estimate a savings of $1 million. Another key factor is the reduction of interface cost, which is oftentimes largely underestimated. By implementing standard interface and pipelines for SAP and DBMS, we have reduced the cost associated with the new system development. It is currently inferenced that we can average out to saving around a full person months of work per system through interface cost cuts with a new system. Manual workload has also reduced when applied to our financial and E&C departments. Manual work time was reduced by 91% compared to our previous estimate. Additionally, by leveraging Excel in MS Teams for data entry, we were able to reduce data entry time to just 1 day. So we are approaching the end. I briefly explained Hanwha Corporation's initiative to maximize data value with Databricks. Thank you for the opportunity to talk with you today. If you have any further questions, please contact me by email. Thank you very much.
Thank you, Haijin. Let me tell you a cool story before we introduce the next presenter. So all the way from Seoul, South Korea, by the way. Haijin. Thank you for making the time. Thank you very much. Thank you for sharing your insights. Cool story about Haijin, just before we hand it over to Dominic. I was in Seoul like last September, and I was like, I don't know what I'm going to do there, and I haven't been there in a long time. And then happened to meet Haijin over there. He's the most warm person in that country, and that country is really welcoming. But fundamentally, he was talking about all of this stuff back in September as a vision, and here we are sitting in June. He's talking about having saved company money, having delivered productivity to workers. That's the magic of Databricks right there. So thank you so much, Haijin, for sharing that story with us. All right, now we're going to switch gears, and we're going to, go worldwide. Obviously, we went worldwide with Haijin, but we're also going into the future of electric vertical takeoff landing and the future of aviation in many ways. And this is exciting part of the presentation set for me because I come from the aviation industry. This is a concept that I've seen explode over the last decade or so, and it's so close to reality, and it's happening right here in the Bay Area. So without further ado, I'm going to invite Dominic Muller from Joby Aviation.